This is a video presentation of Team 1. In Project 2, our team implements a pacman autonomous agent. This is the structure of our presentation. We used the 3 AI techniques: approximate Q-learning, Monte Carlo tree search, and S-star. Based on the table, we finally choose S-stars for both agents. One of the agents is mainly responsible for defense, and another is offensive. But they will transfer to each other under certain situations. For the application of S-star, S-star heuristic search is designed to eat food and keep a safe distance to the ghost. Therefore, distance to the ghost and food are taken as heuristics. According to the state of opponents and the distance to enemies, the goal will be changed. There are 2 challenges for S-star search. The first is boundary condition of the replanning path should be considered detailedly. And another challenge is that when the path is obstructed by opponents, the agent can do nothing but replaning the path. There are also 2 improvements for S-star search. Firstly, when the agent wanders in a small range, it means that the path of the agent is obstructed. Then, new heuristics should be used to determine the route. Secondly, another teammate can draw away the opponent where the path is obstructed. The agent can move close to the opponent and then move away. In the following part, we'll use some demo to discuss the performance of each approach across a variety of scenarios. Firstly, we'll discuss the ability to break through defensive line. The first is Monte Carlo tree search. In order to implement a game state tree needed, the action of the ghost should be predicted, because the ghost shouldn't move randomly in simulation due to the limited computing time. But there is no certain principle to tell the Monte Carlo tree search how the ghost will move during a game. So, this causes the ability to break through defensive line of ghosts becomes difficult if they stand or stroll around the only gap to other side, just like what we showed in the video clip. The second is approximate learning. In the video, we can see that the agent gets stuck after facing the intercept of a ghost because there is no long-term planning shown in the model, which is similar to the Monte Carlo tree search. The third is S-star search. For S-star search, a whole path is calculated according to heuristic and goal. Even though it is facing the intercept of the ghost, it will recompute another reasonable path to eat food or escape, instead of being caught in a local predicament. In the video clip, the agent can easily find a way to break through and escape from being chased by a ghost as well. Then, we'll show some demo about eating food efficiency. The first demo uses approximate learning. The distance to food and the score of next state are chosen as features. In addition, eaten foods are taken as reward to train the model, and the greedy policy is reflected in the decision. So, this model can achieve relatively high food eaten efficiency. The second one is S-star search, as the distance to the food and the distance to ghost is taken as one of the heuristic functions. Reaction is largely affected by the ghost. Therefore, food eating efficiency of S-star is lower than approximate learning model. The last part is the ability to avoid risks. In the video clip, the red team uses S-star search and the blue team uses approximate learning. You can see that the blue team agent is easily to get stuck because the walls and the distance to ghost are used to calculate features. So the fitting of the model will become difficult, especially when ghosts occur inside. This means that the convergence of data will become difficult. Therefore, the risk can't be well presented in the model. Single model always faces the challenge of different environments. At the same time, red agent using S-star can avoid risk better because of its heuristic and computing mechanism based on decision tree. Its heuristic can make it eat food with longer distance to ghost, which makes the agent much safer. In another video clip using a star, you can find that the agent ignores the food, which is surrounded by 3 walls, when being chased by a ghost. A-star agent will avoid to eat foods with high risks. So in conclusion, A-star is the best approach based on our experiments. Thank you for watching.